Okay, sixth grade, we are going to talk about compound events today. This is the last part of probability that we're going to discuss in this chapter. So you'll have a test coming up soon, probably Tuesday or Wednesday of next week, okay, because we need some time to finish this up. All right, let's start with going over the warm-up, okay, and I'll answer the rest of the questions that some of you guys had. Okay, so number one, Emma H., what did you get? Good job. Number two, Adam. Warm-up. Good. Emma M., number three. Good. Who'd they say? Okay, number four, Sean. Okay, that one's a combination because it's basically like groups. The 5 players that they pick, how many ways can those 5 players be chosen? So it's basically like they're talking about groups. Alyssa? Awesome. Number 5, Doug? Uh-huh. Okay. Justin? Good. 10. Jeremy, number 6? Good. Permutation, 120. Matt, number 7? Okay. We're going to talk about this one. That one's actually a permutation. First of all, the keyword display is in there. Secondly, there's some common sense in here that you should be thinking about, and maybe you guys aren't aware of the common sense stuff yet, so we'll talk through that. So if you had P for that one, Mary, what'd you get? Awesome. You probably, yeah, interesting, Adam. It's because I had you carrying baby boxes across the hallway, right? So your brain's a little mushed. Just kidding. Just kidding. Yeah, yeah, I'm just kidding. I had him and Sean carry a present, a big present that was back there, the baby showers today. So I had them help me by carrying that to the library. I know, doesn't it look sad? All right, Briar, number 8. Okay. Justin, number 8. Okay, who had a permutation for number 8? Annalise, what'd you get? Good. Donatus, number 9. Good. Number 10 is Charles. Actually, why don't you tell us? Good. And last one, Mary, number 11. Good. It's Kate. Did you do permutation for that one? No, that's why. Oh, you did. You did. I didn't hear you. Okay. So number 8, you should have 48P3. What did you do? Okay, try it again. You probably just typed it in wrong. That happens. Charles? Yeah. Oh, you know what? Actually, you can't because the things are coming on. Can you wait 5 minutes? You sure? Do you mean to ask if you're allowed to go or no? Sure? Okay. Okay. Like, it should be like 5 minutes. Annalise? Yep. Yes. 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 The wording is just poor. Doug? It's right here. Oh, P. Because music can only be spelled one way correctly. So anytime you're spelling a word, that's going to be permutation. Yes. Yes, and it has the word arranged. Good job. Okay, anyone else on the warm-up? I'm impressed. Raise your hand if you got all those right. Wow. It's amazing how well you guys do at this. Wow, very good. Emma. Number 4 is like groups. So a coach has to pick those 5 players. So he chose the 5 players. So basically what they're asking, the wording is just poor, is how many ways can those 5 players be arranged or be chosen? In what order can those 5 people be chosen? It doesn't matter because they're all going on a trip. Okay, they're all going to the Caribbean. We'll just make that up. So it doesn't matter because they're all getting there, okay? It's just worded kind of poorly. Can anyone explain number 7, why that's a permutation? Oh, a lot of you have your hands up. Sean, what do you think? Mm-hmm. Mm-hmm. Yes, exactly. Does anyone know like the reason behind that? Why grocery stores do that, Briar? Expensive or the name brands? Is that what you're thinking of? Okay. Yeah. Well, they actually, I mean, they might, but I don't, for the most part, I don't think they do. What they typically do is they put the name brand expensive cereals like eye level with the customers. So that's what you see. Typically, the generic brands are above and below, which are the cheaper ones. So anytime I go shopping, I'm always looking up and down to see, you know, how they arrange them because they want you to spend more money. They don't care about our money, right? Just like the end caps. They want it. They want it, Matt. You're right. The end caps, same things. They'll make it be like, oh, there's a big sale. Here's all this stuff. Really, it's probably not that great of a deal. It's just there to get your attention. It might be colorful. So I always walk in with my coupons and try to beat that system that they try to do. And that's the case with all grocery stores. Even if you go shopping, they do the same thing. Mary, go ahead. Go ahead. Yep. Yeah. The healthier ones. Yeah. You're exactly right. MH makes you. So you notice that though when you go shopping with her? Yep. I'll have to look at that. I never noticed that. Maybe that is true. I'll have to look. I don't eat cereal very often, but I'll have to check. Emma? I always eat a banana in the morning. Okay, let me pause this. All right, back to math, guys. Practice 13.3. You had 1 to 19, okay? All right, Briar, start with you on number 1. Good. Sean, number 2. Good. Annalise, number 3. Good. Number 4, Mary. Adam, number 5. Emma M, number 6. Number 7, Jeremy. Good. Donatus, number 8. What? Okay. With a little more enthusiasm, please. Alyssa, number 9. Good. Sorry. All right, number 10, Emma H. Good. Our math class is not boring. Number 11, Doug. Good. Justin, number 12. Good. Matt, 13. Oh, perfect. 14, Briar. Good. Equals. 15. Sean. Say that again. Lesser than. Is that a word? I'll go with it. I'll go with it. 16. Annalise. Yeah. I'm glad the excitement's there. Just say the number right. Perfect. 17, Mary. Just 6? Shh. Hold on. You probably didn't read it. It's not 3 times 2 times 1. Shh. No. It's 6,840. Who can explain the setup of that one? Melissa? Good. It's 20p3. Okay. That's okay. 18, Adam? Perfect. All right, 19, I'm just going to take volunteers. This one definitely made you think. Briar, what'd you get? No? Matt? No? Are you guessing no? No. No, but I'm glad you're having some excitement in there. Justin? No? Doug? No? Emma H? Yeah, Matt did. Alyssa? 30? Oh, I just said the answer. I thought you said 30. No, the answer's 30. Anyone have 30? Oh, I stumped you guys almost. Donatus, did you have 30? Okay, Donatus, I know you're really excited today. Can you explain how you got that? Donatus, a little louder. 5 times 2 times 3, is that what you said? That's all you did? Okay, that's not right. Emma? So 5C3 times 3C2, so it's really 10 times 3, which is 30. So, okay, well, so here's what you had to realize, which I didn't expect you to realize this. I wanted you to try it. This is the multiplication counting principle, but with combinations. So you're trying to find arrangements of the sweaters. I think it was sweaters. Yeah, sweaters, the different textures and then different colors. You're trying to find how many different sweaters are possible. Well, the order that you arrange them doesn't matter because you can still pick out whatever sweater you want. But there's 2 different types. There's 2 different manufacturers that they're talking about. So you have to find the combination of each and then multiply those together because your ultimate goal is to find how many different sweaters are possible still. So I don't know. Does that make sense? Give me a head nod. Kind of. Okay. I haven't decided yet if they'll be that hard on the test. If they are going to be that hard, we'll do more problems like that. If they're going to be that hard, I haven't decided yet. I wanted to see how you guys did on it. Is everyone at least clear on why it's a combination? Okay. All right. We'll do some more of those tomorrow. Okay. Okay. Annalise? For the sweater one? Okay. So since it says the sweater from one manufacturer comes in 5 different colors and 3 different textures, and the buyer decides that the store will stock the sweater in 3 different colors and 2 different textures. So when it asks you how many different sweaters are possible, the order that they either make them or decide how they're going to make them doesn't matter because they're still going to make them. Like if they do make the pink first and then the blue, it doesn't matter because they're still making different textures, different colors, and they're all going to the store. It kind of reminds me of one of those group problems because they're still getting there. So that's why it's combination. And then there's 2 different things going on here, which is why you have to find the combinations separately and then multiply them together. But we will do more of these tomorrow so you guys get a better understanding of how to do them. All right, let's go over the second part of your homework so we can start the next set of notes. Okay, page 7. If I could get there. Okay, number 1 on page 7. Doug, we'll start with you. Good. Number 2, Justin. Good. Matt, number 3. Good. Number 4, Emma H. Perfect. Number 5, Alyssa. Good. Number 6, Donatus. Okay, 15,504. Please a little louder next time. Jeremy, number 7. Awesome. Emma M, number 8. Perfect. 20, or number 9. I'm about to say the answer. Adam, number 9. Good. 24. Mary, number 10. Good. Number 11, Charles. Nope. Annalise, what'd you get for 11? Good, 210. Okay, questions on how to get any of these or questions as to why it's a P or a C? Doug? Yes, because the word group is in there. Okay, Annalise? Yep. It is. What's the answer? Keyword arranged is in there. Keyword arranged always means permutation. And secondly, if you're running a relay race, when you're arranging people for a relay race, like I always think of this as being on a track. I'd rather be on the inner side, the inner lane of the track, as opposed to the outside. Even though it's always a staggered start, I just think mentally, the inner one is easier, and to me it's faster. So the point of that though, Annalise, is when you see the keyword arranged, it's always a permutation. Yep, 4 times 3 times 2 times 1. And that's why the keyword arranged is always a permutation, because it's the same thing as factorial. Alyssa? Yeah, a little bit easier than this. For the most part, did you do okay on this? Okay. The warm-up was confusing, or? Okay. Yeah, and we're not done doing practice with these. I'm going to keep throwing these at you. But yes, it'll be easier on the test. Anyone else? Questions on that? Sure? So thumbs up, thumbs middle, thumbs down on P versus C. Just curious as to where you guys all are. Donatus, thumbs up, thumbs middle, thumbs down. Donatus? Okay, thank you. Mary, does that mean like both? Okay. All right, thank you. Okay, we will do more of that tomorrow. I'm going to type another warm-up for you guys today so we can practice more of P versus C, okay? All right, open up your notes to page 11, I believe. At least I think yours is page 11. At the top, it should say determining probability of a compound event. I wanted to get through both of these today, but I'm not going to have time. So page 11, there's 2 parts to this. I need to teach you the first part first. Okay? So, yeah, we're just going to do 1 part today, 1 part tomorrow, which means your probability test won't be till like Wednesday or Thursday next week. Just in case you like to plan ahead, Matt. They don't have any homework. It's a completely different class than yours, so I don't want to hear the complaining. Yes. Yeah, because their class, I only had them for 28 minutes. All right. Right, that's why I give you more homework. Okay, compound events. So when you think of a compound event, do you guys ever learn that conjunction junction song? Hooking up words and phrases. Okay, she can sing better than I can. So in English, what does a compound sentence mean? What does that song mean? If you guys all think we're crazy if you don't know that song, huh? What does that mean in English, Emma? Compound sentences, yes. Good, in the middle. Good. So guess what? There are such things as compound event math problems, which are just like compound sentences in English. How'd you know that your math teacher would be talking about English? I do. What'd you say, Matt? Conjunction, junction, what's your function? Yes, yes. I'm going to tell you what they are in math words. All right, so first thing I want you to write down is, in English, Sean, is this a comment? Good, real quick. Yeah, well, that's why I'm teaching it to you. Yep, I'm glad you brought that up. So in the English language, there are compound sentences, such as, the dog and the cat jumped over the fence. Okay? Yeah, we just already talked about this. I'm just giving you the point here. Okay? So, compound event, going to math, combines 2 or more events. Now, here's the conjunctions in math. Using the word and, which means multiply. Charles, you with me? Okay, no more calculator playing. Or the word or, which means add. So the conjunctions, Doug, you with me? Okay, in math, the word and the word or. And means multiply, or means add. If you remember, and means multiply and or means add in math, these problems are really easy. Donatus, where's your pencil? Okay, are you with me? Okay. So here are examples. I'm not going to read through these because we're going to do problems like this today. The gold paper that I gave you guys Tuesday morning, I think it was Tuesday, yeah, wanted you to get thinking about cards because a lot of these problems are going to talk about deck of cards, okay? Finding the probability of them and anything like that. All right, so where it says or, I want you to write down or means add. There's two types. There's a type called mutually exclusive, and type 2 is called overlapping. Anyone want to take a guess at the difference between those types? Mutually exclusive versus overlapping. Annalise, you want to take a guess? Common sense. Yeah. Okay, you're close. That's all right. Good guess. Esma H. Great job. Adam? No, but you guys are getting there. Emma? No. Any other quick guesses? If not, I'll tell you. I thought you guys would get this. Charles? Which one? Are you saying they're both different? Wait. Charles, you're confusing me. You're saying overlapping's different? Well, obviously. Right? Or are you kidding? Or are you serious? Okay. I remember I asked. Sorry, Charles. I thought you were being sarcastic. The two types are different. Okay. I know you're playing on your calculator, but we're talking about the difference between them. All right. Well, so do we. Okay. All right. So, okay, go ahead, and then I'll tell you. Charles. Yeah. But that's true for both of them. All right, so I'll just tell you. Let me just tell you. Mutually exclusive, they have nothing in common. Overlapping, common sense, they have something in common, right? They overlap. So if you think of a Venn diagram, overlapping, they have something in common. Mutually exclusive, they have nothing in common. There's stuff here and there's stuff here, but there's nothing in the middle. Overlapping, they have stuff everywhere that they share. We're going to talk about this today. So, type 1, mutually exclusive, no common outcomes. Mutually exclusive events have no common outcomes. For example, when you have a deck of cards, the probability of choosing a king or an odd number, they have nothing in common. There are not any kings that have an odd number. When you're rolling a number cube, the probability of rolling a composite number or rolling an odd number. Okay, they have no, oh, no, I'm wrong. Sorry. When you're rolling a number cube, let me say that again. Probability of rolling an odd number or an even number. Why did I tell you that I was wrong with my composite thing? 9, right, and 15. There's a lot of composite numbers that are odd, so sorry, my fault. Yeah, I know, but I stopped just in case we have a 10-sided number cube or a 20-sided. You're right. So maybe I was kind of right. Okay, so let's do an example. The probability of drawing the king of hearts or drawing a spade out of a standard 52 deck of cards. Okay, they have nothing in common. I want you to circle the word or, which means add, put a plus sign above it. We are finding the probability of a king of hearts or a spade. Okay, what is the probability that we're going to get a king of hearts from a deck of cards? Alyssa. Good, 1 out of 52. Plus, we're adding them because or means add. What's the probability of drawing a spade? Justin. Good, 13 out of 52. Okay, when you add fractions, we've already done this. We get 14 out of 52. So reduced, what is the probability that we're going to get a king of hearts or a spade? Adam? 7 out of 26. Pretty easy, right? Doug, question? Well, that's because you weren't here when we did this. That gold paper that you had, there's one king of hearts out of a deck of cards. There's a total of 52 cards in a standard deck. Favorable over total. There's 13 spades. Yeah, take out your gold paper. It shows you at the top. And guys, don't forget I told you on Tuesday, if you need your gold paper, if you don't understand how cards work, look at that gold paper. That's why I gave that to you. The top of it tells you. Charles. That would be fun. Okay, let's do one more of these, and I want to show you the next type. Okay, number 2, find the probability of rolling a 3 or an even number. You guys are finding this pretty easy, right? Or means add. But you're adding them still. Okay, probability of rolling a 3, so a number 3, or even number. Okay, how many number 3s are on a 6-sided number cube? Justin. Good, so 1 out of 6, plus how many even numbers are on a number cube? Alyssa? Good, 3. So plus 3 out of 6, add them, we get 4 out of 6, which is 2/3. So there's a 2/3 chance that you're going to get a 3 or an even number. Annalise? Yeah, why is that mutually exclusive? These are all mutually exclusive. They have nothing in common. A 3 is not an even number. Yep. So underneath type 1, all these 3 examples are mutually exclusive. Yes, eventually I'm going to mix them up. Okay, let's flip over so I can show you overlapping, and then that's the only other type I'm going to show you today. Okay? So let me show you what overlapping is. So type 2, overlapping events. So I was hoping you guys would figure this out, but that's okay. 2 events that have at least one common outcome. Mutually exclusive, they have nothing in common. Overlapping, they have at least one common outcome. Now, I'm going to go through this with steps. Yeah, we'll still go through them with steps just to make sure you understand the process. Yeah, okay, so example 1, find the probability of us rolling an even number or the number 2 on a 6-sided number cube. So why is this one overlapping? Sean? Good, 2 is an even number. They have something in common, so it's an overlapping event. So it just goes through and breaks these down into steps. You don't have to do this, but I'm going to still do this. Okay, determine the probability of each event. So Jeremy, what's the probability that we're going to get an even number? You okay? Okay, good, but don't reduce. Okay, leave it as 3/6 for now. Okay, Mary, what's the probability that we're going to get a number 2 on a number cube? 1/6, good. Okay, so don't reduce them. Step 2, add these together, don't reduce. So Matt, what's 3/6 plus 1/6? Good, so we're adding the probabilities together separately. Determine the probability of the overlapping parts. I want you guys to draw 2 Venn diagrams here, or draw a Venn diagram, I should say. And here's what I want you to do. Even numbers on a number cube, 2, 4, and 6. So on this side of the Venn diagram, make the even numbers. On this side, I'm going to put a number 2 because we have to find the probability of it being an even number or a number 2. What do both sides of the Venn diagram have in common, Alyssa? Okay, I'm going to circle the 2, and I'm going to write it in the middle. What is the fraction of the overlapping parts? I hope that the Venn diagram helps. Doug? Good. So they have 1/6 in common because they have one thing in common. The Venn diagrams are helpful with card problems as well when you have overlapping things. Okay? So it says for step 4, subtract the probability in step 2. Subtract that probability from step 2. So we take 4/6, which is us adding the probabilities separately together, minus the overlapping part, which is 1/6. We get 3/6, which is 1/2. Emma. That's not always going to be the case. In this one, it works, though. I'm glad you're thinking, though. Annalise? They have one thing in common. These are the even numbers. This is the number 2. So on both sides of your Venn diagram, they have a 2 in common. They have one number in common out of 6. So the middle of your Venn diagram is what they have in common. Okay, does everyone understand that, why that Venn diagram's there? Okay. Yep. I'm going to do it. Let me do it all in one step. I don't like all these steps. So let me do a problem. Let's just do it all in one step. Okay, example 2. What is the probability of rolling an odd number or a prime number on a 6-sided number cube? So let's start this one. Forget about the steps. Let's make a Venn diagram. These are going to be odd numbers. These are going to be prime numbers. This is probably going to be easier. Okay, what are the odd numbers on a 6-sided number cube, Matt? Good. So everyone write 1, 3, and 5 in your Venn diagram. What are the prime numbers on a 6-sided number cube, Briar? No. 1 is neither prime nor composite. Justin? Good. 2, 3, and 5. Okay, is everyone clear on how we started the Venn diagram? What goes in the middle? What can we circle? Annalise, what can we circle? A 3 and a 5. So in the middle, what you circle, you write in the middle. What's the fraction of the overlapping parts? Doug? 2/6. They have 2 things in common out of 6. So the fraction of the overlapping parts is 2/6. So we need to take the probability of odd numbers plus probability of prime numbers minus the overlap. Add the probabilities together, subtract the overlap. Does that make sense? How we set it up? Charles? I know. To me, it's easier instead of like actually doing 4 steps, just do it all at once. But you're right. You don't or you do? You don't? Okay. You don't, maybe you're not, you're not a visual learner then? But then don't use that. That's why. If you're a visual learner, do you understand the Venn diagram? You don't have to use it. It's just, if it's helpful, if you don't like me talking through it, use this. Like if you don't like me explaining all these steps. So Charles, just so I can make sure you understand this part. Okay. Annalise? Because that's what they have in common. It's kind of like whenever you're doing letter arrangements, whatever they have in common, you have to divide by it. You have to find the probability of odd or prime, but they have things in common. So if it's an overlapping event, you have to subtract what they have in common or it's not going to be the correct probability. If you added these without Annalise, it'd be 6/6, which is 100%. That's not the probability. Okay, because you're not going to get an odd or a prime 100% of the time. That's not true. So you have to subtract what they have in common. So we get 4/6, which is 2/3. Thumbs up, thumbs up, thumbs down. What do you think of this compared to P versus C? I'm just curious. I wish I had more time today.
Yeah, C versus C.
Okay. I'm just curious, easy, hard, middle. Okay. All right, so I need to stop so I'm not late. Okay, I'm just going to give you guys a little bit of homework. I wanted to give you more, but obviously there's not time. So open up your homework packet, and I will finish this tomorrow. So listen, I just want you to try the homework. What I want you to focus on tonight is knowing whether it's mutually exclusive or overlapping. Does it have something in common or does it not? Okay, so homework packet page 19. Okay, so page 19 and 20, I only want you to do 1 through 6. No, just total, 1 through 6. I don't want you guys to be doing it wrong, so just do 1 through 6. I know. That's why don't go to page 21 is my point. Did everyone find? So what you need to do is list the numbers of the events. If you want to make a Venn diagram, go ahead. If not, you don't have to. Determine whether it's mutually exclusive or overlapping, and then put your simplified answer. I am going to spend much more time on this tomorrow. The drill kind of messed me up today, so we okay? All right, let's get packed up. Good job today. No, I'm going to teach you that tomorrow.
Wait, the what?
We're going to do it, yeah. The independent and dependent.